We have already created a retrofit service, WeatherNetworkDataSource as an abstraction on top of that service, local database with entities and DAO using the room library, and lastly a repository to rule them all. So technically speaking, we currently have the model layer done. What's missing to have a functioning MVVM application is precisely the ViewModel and the view. In this part, we are going to implement them so that we will have the architecture all set up and prepared for adding a nice user interface in the next part. You are going to learn how to perform a lazy loading with coroutines in Kotlin, how to connect ViewModel to a repository, how to safely call coroutines from a lifecycle-bound component, such as a fragment, and much more. Hello, welcome to ResoCoder, and before we jump into implementing the view and the ViewModel layer, let's first do a quick fix. In the previous part, we used something called zoned datetime. Zoned datetime is a part of the Android 3.10 backport library, and before we manipulate with time or dates with that library, we need to initialize it first. The best way to initialize a library such as this Android 3.10 backport is in the onCreate method or function of our application. Since we already have this application created because we are using Kotlin here for dependency injection, we are going to create or override onCreate over here. And inside it, we first want to call super onCreate, and then we want to write Android 3.10. And we want to initialize it with a context, which is this. When we were creating the basic scaffold of our app in the first part, we already created also the view model, which is present under UI, weather, current, and then current weather view model. But for now, this view model is completely empty, so let's change it. For now, this class will have one private val inside its constructor, and it's going to be forecast repository. And always be sure to select the interface and not the implementation. And now what do we want to do in this class? Well, we want to have some kind of a way for the view to fetch the weather. The fetching of the weather for the fragment needs to happen through this view model, so it will be some kind of a middleman. For that reason, our view model needs to communicate with our repository and then expose that data for our view. The best thing about model view model architectural pattern is that the view model doesn't know about the view. The view model only exposes data for the view, and then it's up to the view to fetch it. So we have absolutely loose coupling everywhere. If you want to learn more about MVVM in depth, you can check out my separate tutorial by clicking on the card in the corner. So for now, let's expose one public property. It will be immutable weather. And well, we want to get it from a forecast repository, right? So we can just write equals forecast repository dot get current weather. And then we somehow need to pass in whether it is metric or not, meaning that it's imperial. And by the way, get current weather on the repository returns live data object, so we will be able to observe this weather from the view. So first, let's figure out how are we going to pass in whether we should fetch the metric weather or the imperial weather. Well, we need to have some kind of a boolean for checking if we have metric currently turned on or if we are operating with imperial. So let's create val is metric. It's going to return a boolean, and it's going to be a read-only property, so it will have only a getter, and we could return for now only true over here, but I am going to take it up a notch. We know that we are gonna have to work with settings and somehow get a value from the settings which the user will set manually, and that value will say if we should load metric or imperial weather. So we can create private val unit system, and this will be set either to metric or imperial, and later we are going to get it from settings, so get from settings later. For now, however, we are going to hard code the value for the unit system. And what is the best option to set here? Well, we could just write some string over here, so metric or imperial, but that is not really good or type safe or anything like that. We can just misspell something like metric with K on the end, and it's not going to work well. For that, we are going to use Enums. We are going to create such an enum inside the internal package. So right click on internal. We want to create a new Kotlin class or enum class actually, and it's going to be called unit system. All right, pretty nice. And it's going to have just two values, metric and imperial. Now, when we come over to our current weather view model, we can set this unit system to be equal to unit system dot metric. For now, it will be hard-coded, and later we will get it from settings as I write in this comment. So inside this isMetric check, we want to return if unit system is equal to unit system.metric. So this means that now we can pass isMetric over to this getCurrentWeather function call. So just like this, and it's all going to work properly or not. Why is it not working? Well, because it's not called from within a suspending function or a coroutine context. But this is actually not our only problem. It's not that this is going to kill us or anything, but whenever the current weather view model is instantiated as an object, this weather will be gotten immediately. Kotlin has a nice way of making such calls lazy. This means that if we made this weather property lazy, it would not be initialized instantly as the current weather view model is instantiated. Rather, it would wait for it to be called. So only when the view would call that, hey, I need the weather right now, the weather property would check, am I initialized already? If it is, it's not going to call again this getCurrentWeather. However, if it's not initialized yet, it's going to call it and then store the value which it got from this getCurrentWeather as live data. So let's implement such a lazy property. Usually we would do this in this way by specifying by and then lazy, and then just simply put all of this code over to this block of lazy, and we would be kind of good to go. But we are not good to go right now because this needs to be called from a coroutine context, and lazy block doesn't specify or doesn't provide any coroutine context currently. In order to change that, let's create our own little function like this lazy, and it's going to be called lazy deferred. So let's create it right now. We want to create a new file under internal, and we are going to call this delegates. And in this file, we want to have one function lazy deferred. So it's going to be a function. It's going to take in a generic type, and it's going to be called lazy deferred. Now, this function will take in a block of code, and this block of code will be some kind of an embedded suspending function. So it's going to have the suspend modifier, and it's going to be something which is executed on coroutine scope. So this is the syntax for it, coroutine scope and then parentheses, and let's also implement or import coroutine scope over here. And this block of code will return t. So basically this is a higher order suspending function. Now we also need to specify the return type for the whole of this lazy deferred function, and that will be a lazy. This is already provided for us through the Kotlin standard library. And this lazy will hold inside of it a deferred, and the deferred will hold inside of it whatever is the type t. Alright, from this function, now we want to return lazy, so we are going to utilize this lazy because we don't want to reinvent the wheel, right? We want to utilize whatever we have and only write the minimum possible amount of code. So let's return lazy, let's reuse what we already have. And inside this lazy, we are going to call global scope async. So we are using global scope, but that doesn't really matter over here. In this part, I'm also going to finally show you how you cannot use global scope, but use local scope. But that will come later in this part, so stay tuned for that. Also, another important thing for this async call is to specify its start. And it's going to be coroutine start lazy, because we want this whole thing to be lazy, so even the start of the coroutine needs to be lazy, meaning that this coroutine will be launched only when this lazy deferred is called, and when this lazy in turn is called, and that whole thing will be launched only once we call the weather. So whenever we need the weather for the first time from the view, this whole chain of calls will be initiated. And from this async, let's call block.invoke, and let's invoke it with this. This is the coroutine scope, as we can see over here. Alright, I know that this can be quite a lot to digest at one time, but just have a nice look at it, and remember that you can also get the code from the link in the video description, which is going to take you to resocoder.com. Now let's come back to current weather view model, and we are going to replace this lazy with lazy deferred. And now we are all good to go. Now some of you may think that once we have this current weather view model implemented, all we can do is to jump right into the current weather fragment and create the current weather view model over there and start using it, right? Well, it's not so simple. We also need to create current weather view model factory. The reason for that is simple. View models are all about preserving state. So for example, if you have the screen rotation and the configuration of your app changes, the data which is stored inside the view model will be not destroyed, such as the data from the activity or fragment, because fragments data will get destroyed every single time. For that reason, because it's not destroyed, we cannot always just create a new instance of current weather view model, or any view model for that matter, from inside our views. We only want to create a new instance of our view models during the first launch of the view. So for example, during the first launch of our current weather fragment. Then on subsequent launches, for example, when it's destroyed and then it's recreated again, we want to get the already present instance of current weather view model, because we don't want to lose its state. We don't want to lose whatever is inside this weather property. All of this is possible through the ViewModel factory, because that will handle the saving of our current instance of our view models for us. All we need to do is to create it. So let's create one under current. We want to create a new Kotlin class, current weather view model factory. Then we also need to specify the forecast repository as a constructor parameter or property also in this current weather view model factory. So private val forecast repository. Then this class will inherit from view model provider, and then a new instance factory. And over here we want to override only one function, that is create, and it will return the current weather view model. So instantiate that with the forecast repository and also cast it as t. And this is an unchecked cast, so let's suppress it on the fun create. So it adds one nice little annotation which suppresses unchecked cast. Alright, so now that we have this, let's go to current weather fragment and let's start working, right? All we need over here is the view model factory. So private val view model factory. And some of you may already anticipate what I am going to say here, and that is that it's not alright to just simply instantiate it right over here. So current weather view model factory, that is not good practice to do. We cannot do just this and then pass in the repository, because then we would also need to instantiate a repository over here, and that is just no good. In fact, we have already bound our repository inside the forecast application class with the Kotlin dependency injection. What we need to do next is to also bind our current weather view model factory with this Kotlin dependency injection. So let's write bind, and because our view model factory doesn't have any interface, we can just simply directly bind it from, and we want to bind it from provider, because it doesn't need to be a singleton. This bind call can always return a new instance of our factory. So it will instantiate current weather view model factory, and it's going to pass in an instance, which in this case will be of type forecast repository. Alright, now let's come back to current weather fragment, and we are going to make this fragment Kotlin aware. So it needs to override Kotlin, and this Kotlin property will be lazy. So let's instantiate it by closest Kotlin. The closest codin will get whatever codin is the closest, obviously, and in our case the closest codin is the one inside forecast application. You can also have local codin, so you can have local fragment codin, which will override some functionality, but we aren't going to delve into that in this tutorial. However, that is really nice feature of Kotlin, so I think that it's good to know. And now this ViewModel factory will be equal, or actually not even equal, it will be simply by instance. So this is the same syntax as over in forecast application. We want to get the instance of our current weather ViewModel factory. However, now we have an error, and that is because we cannot infer the type of our ViewModel factory. We need to specify it over here, so it will be current weather ViewModel factory. Now we can actually get rid of this companion object because we are not going to need it for our fragment. Then inside onActivity created, we are getting the instance of our ViewModel, and we need to change a bit how we do it. All we need to change here is to pass in our ViewModel factory right after this, inside this off call, right behind the this, which is the fragment. So ViewModel factory, pass it over here, then format the code a bit so that we can see it properly, and here we are good to go. Alright, now we aren't going to need this code anymore, but for now I'm just going to comment it out because later on in this tutorial I will be copying some parts of it, but then on I will delete it completely. We can also get rid of this to do for good. And let's create a function for binding the UI. So private fun bind UI. Then we are going to call this function from onActivity created. And from this bind UI, we first want to get the current weather. So val current weather. And the only place that we can get this weather from is from our current weather ViewModel by calling the weather property right over here. So let's get it by simply calling ViewModel. From that we want to get the weather, and then we want to await this weather because it's deferred. We have a small problem though, because we cannot call await from a non-suspending function or not from a coroutine scope. So the simplest option is to specify that this bind UI will call this block of code inside a launch coroutine. So global scope dot launch. But here the problem is, as always, that launch is not safe to use from something that has a lifecycle, and Fragment has a lifecycle, so it's not good to call something on a global scope from within a fragment, because in case that this launch finishes only after the fragment is already destroyed, we are going to crash the app. For that reason, now let's create a local scope. And this is something so crucial and so fundamental that we will use it throughout all of our fragments, and for that reason I'm going to create it in a special fragment class. So first let's even create a new package under UI, and it will be called base. Inside it let's create a new Kotlin class, and it will be called scoped fragment. And this scoped fragment will be an abstract class, because it cannot be instantiated by itself. It's going to inherit from fragment, and also it will be a coroutine scope. Every time that you call launch, for example even this launch, you can then call dot cancel on this job, and it will be cancelled immediately. We are going to use this fact in our scoped fragment. So let's go back over there, and we are going to have one private late init job inside this scoped fragment. So job of type job. Now because this scoped fragment is also a coroutine scope, we are also going to override coroutine context property. And it's going to be a read-only property, and it's gonna be equal to job plus dispatchers.main. In this case, the plus operator means that this job will be running on the main dispatcher, which means it will be running on the main thread. And remember that everything that operates with the UI on Android has to run in the main thread, otherwise we cannot operate with the UI, we cannot change the state of the UI or any such things. And now the best part, we are going to override onCreate, which is a standard lifecycle method or function as it's called in Kotlin. And over here we are going to instantiate the job. So job equals a new job. And then the best part is undestroy. And over here, we simply want to call job.cancel. So whenever the fragment is destroyed, we are going to cancel the job and we are going to prevent any kind of exception, any kind of crashing of our app. So now what we can do is to go to our current weather fragment and make it to be an instance of scoped fragment, or rather a subclass of scoped fragment. And now we can simply call launch without the global scope. We can call launch as this because our fragment is now inheriting from scoped fragment, and this scoped fragment is now itself an instance of coroutine scope. And yeah, so we can call it like this, and now we can call current weather dot observe, and we want to observe not forever but only within the current life cycle, and its owner is this current weather fragment. And then we also want to specify the observer. And inside this observer, we simply want to set the text view .text to be equal to it, which is the unit specific current weather entry, and then we want to convert it to string. So basically, the user should not be able to spot a difference in our app, but for us, the programmers, now we have the architecture all set up, and in the next part we can just drop in the nice user interface, connect it all up inside this bind UI function, and it's going to be running perfectly. So actually we can get rid of this commented out code. I didn't even use it, even though I thought that I would use it. And now all that's left to do is to run our app and test it if it works. And sadly, our app crashed. When we take a look inside the logcat, we can see that we cannot call a virtual method to string on a null object reference. And it happens inside current weather fragment line 51, which is precisely this thing. So we are trying to convert to string a null instance of unit specific current weather. This happens simply because we are observing some data, and we are observing it from a database, and that database doesn't currently have anything stored inside it, and because of that it simply returns null data. We can fix it pretty simply by only adding a null check over here. So if it is null, then we want to return from the observer. And also you should remember that this observed will be continually called every time there is some change in the data. So even though the first time that this observer is called with null data, once the data is in there, once it's inside the local database, this observer will be called once again, and this will be no longer null. So we will continue with the code and we will set the text view to contain the string. So let's run it even once more. So I am going to launch it. And we can see that it surely works. We have here the metric current weather entry with all of its data. We can even go to the next fragment by clicking on 7 days and then come back, and it's still going to be over here. So everything is working properly. And let's also test if it still works without the data connection. So let's turn off our LTE. Let's launch the app and it still works. And now we even have metric current weather entry over here because we pull it from our local database, and our local database has that data even though we don't have the network connection. So basically everything is working as it should. And that's it for this tutorial. If you don't want to miss the next part in which we will be implementing and connecting our nice user interface, definitely subscribe to this channel and also hit the bell button so that you will be actually notified about all of my new videos. If this video helped you with implementing your view models and view model factories and connecting it all up, give this video a like and also share it. Remember that you can get the code written in this tutorial from the link in the video description, which is going to take you to resocoder.com. Leave a comment if you have anything to say, follow me on Instagram, Facebook and Twitter, and see you in the next video.